Welcome! Today we'll find the points on a cubic curve where the tangent line is parallel to the x-axis. Our curve is y equals x cubed minus 3x plus 2. Let's approach this step by step. First, let's understand what it means for a tangent to be parallel to the x-axis. A horizontal tangent line means the slope at that point is 0. And we know that the derivative gives us the slope at any point. Step 2, let's find the derivative of our function. The derivative of x cubed is 3x squared. The derivative of negative 3x is negative 3. And the derivative of 2 is 0. So our derivative is 3x squared minus 3. Step 3. Set the derivative equal to 0 and solve for x. 3x squared minus 3 equals 0. Add 3 to both sides. 3x squared equals 3. Divide both sides by 3. X squared equals 1. Therefore, x equals plus or minus 1. Step 4. Now that we have our x values, let's find the corresponding y values by plugging these x values back into our original equation. When x equals 1, y equals 1 cubed minus 3 times 1 plus 2, which equals 0. When x equals negative 1, y equals negative 1 cubed minus 3 times negative 1 plus 2, which equals 4. Let's visualize this on a graph. Here's our cubic function. The points where the tangent is horizontal are at 1, 0, and dash 1, 4. At these points, you can see that the tangent lines are indeed parallel to the x-axis. In conclusion, we found that the tangent line is horizontal at 2 points, 1, 0, and dash 1, 4. We found these points by, first, taking the derivative to find the slope function, second, setting the derivative equal to 0 to find the x values, and finally, plugging these x values back into the original equation to find the y values.